The Earth, the home for nearly 8 billion people, more than 20 billions of animals, and more than 3 trillion of trees. Today, the Earth is weeping due to environmental pollution. Improper ways of discharging waste are a key reason for this pollution. Open landfills and garbage dumps are big contributors for land pollution. An open landfill is also a polluter of freshwater streams through leaching of pollutants as well as air pollution due to emission of toxic gases from garbage heaps. Improper discharge of plastic waste mixed with organic garbage creates the microplastics problem. Microplastics accumulated in aquatic bodies penetrates animal bodies and then into human bodies. Avoidance of microplastics is going to be one of the biggest challenges for sustainable waste management in the future world. Industrial solid wastes like boiler ashes and different sludges also need improved waste management technologies rather than conventional landfill dumping. Wastewater and effluents are the next culprits of water source pollution. The pollutants in the forms of suspended solids and dissolved solids mixed with natural water sources have gradually downgraded the drinking quality of natural water. The natural aquatic bodies are no longer safe for direct consumption without any prior applications of water treatment technologies. Large-scale wastewater and effluent treatment facilities are a mandatory requirement for almost all industries that would consume additional amounts of resources. However, proper waste management approaches can provide opportunities for sustainable improvements through waste valorization. One example is biogas generation from effluents through anaerobic digestion, novel bioreactors, and membrane technologies. Airborne pollution, another dark side of waste gas emissions. Various industries, especially the ones that consume fossil fuels for energy supply, emit various pollutant gases such as carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxides, particulate matter, non-methane volatile organic carbons, and many others. Even end-of-pipe treatment technologies are applied. The airborne emission control is challenging. These airborne emissions have major environmental impacts like global warming, acidification, photochemical smog formation, and even toxicity impacts on human health, flora, and fauna. The present world is having many polluted cities and contaminated air quality in most of the highly populated areas. Destructive human interventions like deforestation increase the severity of these emissions and the associated environmental impacts. Sustainable waste management. urgently requires actions starting from waste source identification, source separation, and source reduction. The most desirable mitigatory actions for solid wastes, waterborne and airborne emissions, lie around eliminating their generation, which is a key initiative in 3R or 5R concepts named as reduce. For the generated waste, proper collection techniques, waste segregation at the source of generation, as well as at collection centers called as material recovery centers, helps for resources recovery from waste that promotes reuse in other possible applications and recycle for the same application. In addition to reduce, reuse and recycle strategies, waste to energy options are also helpful for effective waste management. Fast and slow pyrolysis techniques as well as incineration of solid wastes can be the waste to energy opportunities. Sanitary landfilling can be applied for wastes having no sustainable waste management strategies. Waste minimization is more desirable in sustainable waste management. In the hierarchy of waste management, waste source reduction, reuse, and recycling strategies are ranked as the most preferable, respectively. Resources recovery and waste to energy approaches are preferable strategies for disposable waste, which are not possible to reuse or recycle. Landfilling is the least preferred method, while in such case, sanitary landfilling is recommended over open landfilling. To identify the most appropriate strategy in waste management policy and decision making, life cycle assessment of different waste management scenarios is essential. The environmental, social, and economic feasibility of implementing waste management strategies can be systematically analyzed and compared using the standard life cycle assessment methodology. The life cycle of each waste type can be integrated with a closed loop linking for the same product life cycle or another product life cycle through these waste management initiatives. This is what's simply called as circular economy, where the world is eagerly heading to. The sustainable waste management initiatives can be linked to clean renewable energy like solar energy, wind energy, and other sustainable energy solutions. Benevolent human actions like reforestation, green chemistry, and green engineering approaches that enhances the level of responsibilities, decision making, and policy making by the technically related professionals engaged in industrial processes and services. Setting up a customized sustainability agenda, assessment of sustainability indicators like carbon footprint, water footprint, energy footprint, and other life cycle impacts in environmental, social, and economic perspectives will be the prioritized actions by every organization and individual for the next decade in order to reach the sustainable goals and targets. Sustainable process engineering is the key subject area combining all these sustainability related concepts, methodologies, and their implementation actions and strategies. The journey of sustainable waste management, circular economy initiatives, and overall sustainable process engineering approaches will enhance the quality of life and make the earth a better place for tomorrow.